In the present video, we will discuss the processing n jobs through 3 missions. These problems we can solve by Johnson's extension rule for 3 mission scheduling. To apply the Johnson's rule for 3 mission n job scheduling problem, the given data need to satisfy one of the following conditions or the both. So first condition is maximum processing time of mission 2 should be less than or equal to minimum processing time of mission 1. Second condition is maximum processing time of mission 2 should be less than or equal to the minimum processing time of mission 3. So to apply the Johnson's rule for the 3 mission and n job scheduling problem, given data should be satisfied both of the two conditions or any one of the condition. Let's see the method for solving the problem. First step is given problem is replaced with an equivalent problem involving n jobs and two fictitious missions mg and mh, and define the corresponding processing time as mg equal to mission 1 plus mission 2, mh equal to the mission 2 plus mission 3. Step 2 is now the newly produced table will represent a 2 mission n job scheduling problem. So the optimal solution resulting from this table shall also be the optimal sequence for the given problem. So first we have to convert the 3 mission problem into 2 missions problem. After that we have to apply the Johnson's method of the n jobs and 2 mission rule. Then we have to form the job sequence. And this job sequence also suitable for the n jobs and the 3 missions. Let's see the example problem. Find the make span for the following 3 mission problem. So here given the missions, 3 missions, mission 1, mission 2, mission 3, and the 4 jobs are given, job 1, job 2, job 3 and job 4, and respected processing time also given. Then you have to determine the make span, or maybe you have to determine the total completion time. So you have to apply the Johnson's rule for the 3 mission n job scheduling problem. Before that one have to check the data whether it is satisfying the two condition. One condition is the maximum processing time of the mission 2 should be less than or equal to the minimum processing time of the mission 1. Second condition is the maximum processing time of the mission 2 should be less than or equal to the minimum processing time of the mission 3. So in the data, maximum processing time for the mission 2 is the 10. Similarly, minimum processing time on the mission 1 is the 3. So maximum processing time of the mission 2 is the 10 and minimum processing time of the mission 1 is the 3. But 10 is not less than the 3 and moreover 10 is not equal to the 3. So first condition is not satisfying. Then I have to check the second condition. So here maximum of the processing time of mission 2 is the 10 and minimum processing time on the mission 3 is the 10. So here 10 equal to the 10. Then the among the two condition, given data is satisfying the second condition. So we can have to go for the Johnson's extension rule for the 3 mission n job scheduling. Let's start the solution. So condition is satisfied, then have to apply the Johnson's rule. So the given problem is replaced with an equivalent involving n jobs and 2 fictitious missions, that is the mg and mh, and these missions are defined as the mission g mg equal to the M1 plus M2. Similarly, mission H equal to the mission 2 plus mission 3. So we have to convert the 3 mission problem into 2 mission problem. The 2 missions are the MG and MH. So MG processing times are the, for the job 1, so 3 plus 8 which is equal to the 11. For the job 2, 12 plus 9 which is equal to the 21. And for the job 3, 8 plus 6 which is equal to the 14. And for the job 4, 12 plus 10 which is equal to the 22. Similarly, mission H equal to the defined as the M2 plus M3. So for the job 1, processing time of the mission 2 plus mission 3, that is 8 plus 10 which is equal to the 18. Similarly, for the job 2, 9 plus 12 which is equal to the 21. For the job 3, 6 plus 13, 19. And for the job 4, 10 plus 16 which is equal to the 26. We converted the 3 missions problem, M1, M2, 3 missions problem into the 2 missions problem. That is, the 2 missions are the MG and MH. Then we have to find the sequence by applying the Johnson's rule. So in the Johnson's first rule, first we have to draw the cell, size of the cell which is equal to the number of jobs. So here number of jobs are the 4 jobs. So size of the cell is the 4 cells. After that we have to observe the processing times of the all the missions. Here 11 is the minimum processing time among the all the processing times, which is related to the job 1 on the mission G. So we have to allocate the job 1 on leftmost vacant cell. So in the job sequencing order, we have to fill the job 1 is the leftmost vacant cell. So then we have to remove the job 1 for the consideration. So next we have to observe the processing times. So here 14 is the minimum processing time among the all the processing times, which is related to the job 3 on mission G. So we have to allocate the job 3 on the leftmost vacant cell. So I have to allocate the job 3 on the leftmost vacant cell. Then we have to remove the job 3 for the next considerations. So next, once again I have to observe the processing times. Here 21 is the minimum processing time among the all the processing times, but which is related to the job 2 on mission G and also job 2 on mission H. So we have to allocate the job 2 on the leftmost vacant cell, or we have to allocate the job 2 on rightmost vacant cell. So first we have to allocate the J2 on the leftmost vacant cell, or maybe we have to allocate the job J2 on the rightmost vacant cell. So now here it is forming the two kind of the sequencing order. So we will get the both of the solution is the same. So later we will be check. So okay, so next one there is the remaining only one job. So that is the J4. So in the first sequencing order we have to fill the J4. Similarly in the second sequencing order also have to fill the job J4. Next we have to calculate the time span or total completion time for the two sequencing orders, that is the J1, J3, J4, J2. Another one is the J1, J3, J2, J4. So for this one I have to draw the tabular column, which is consisting of the first column job. So here in the first column I have to write down the job sequencing order. Second column is the mission 1 in time as well as the out time. Next column mission 2 in time and out time. Next column mission 3 in time as well as the out time, and next one is the completion time for the respected jobs. So first we have to start with the first sequencing order J1, J3, J4, J2. So write down the in the job column sequencing order J1, J3, J4 and the J2. So next I have to go for the calculation of completion time for the first job, that is the J1. So J1 job has to be moved to the machine 1. So J1 is the first job and machine 1 is also first machine. So in time should be the 0 and out time is the in time plus processing time. So here processing time is the 3. So 0 plus 3 which is equal to the 3. So after the 3 hours, job J1 has to be moved to the machine 2. So in time on machine 2 is the 3 and out time is the 3 plus processing time is the 8, that is the 11. Then after the 11 hours, job J1 has to be moved to the machine 3. So in time is the 11 and out time is the 11 plus 10 which is equal to the 21 and total completion time is the 21. So next I have to look for the next job J3. So job J3 has to be moved to the first machine 1, but up to the 3 hours machine 1 is busy with the job J1. So after the 3 hours machine 1 is the free, then have to engage the after the 3 hours job J3. So in time for the job J3 on machine 1 is the 3 and processing time is the for the job J3 on machine 1 is the 8. Then out time is the 3 plus 8 which is equal to the 11. So after the 11 hours, job J3 has to be moved to the machine 2. Similarly, up to the 11 hours, machine 2 also busy. Then after the 11 hours only, job J3 has to be moved to the on machine 2. So in time for the job J3 on machine 2 is the 11 and the processing time is the 6. So out time is the 11 plus 6 which is equal to the 17. So after the 17 hours, job J3 has to be moved to the machine 3, but machine 3 is engaging up to the 21 hours with the previous job, that is the J1. So after the 21 hours only it will be receive the job J3. So in time for the job J3 on machine 3 is the 21 and the processing time is the 13. So 21 plus 13 which is equal to the 34 and total completion time for the job J3 is 34. So next one is the job J4 on the machine 1 is the 11 because up to 11 hours machine 1 is busy with the previous jobs job J1 and J3. Then after the 11 hours only it will be receive the new job, that is the J4. Then out time is the in time plus processing time. So processing time is the 12. So 11 plus 12 which is equal to the 23. So next after the 23 hours job J4 has to be moved to the machine 2. So here observe 17 hours, after the 17 hours machine 2 is free, but job J4 is busy with the on the machine 1 up to the 23 hours. So after the 23 hours only it will be moved to the machine 2. So in time for the job J4 on machine 2 is the 23 and the processing time is the 10. So 23 plus 10 which is equal to the 10. So 33. So next, so job J4 has to be moved to the machine 3. Here observe the out time of the machine 2 as well as out time of the machine 3. So here 34 having the maximum time, so have to in time is the 34 and processing time is the 16. So 34 plus 16 which is equal to the 50. So next I have to go for the job J2. So job J2 has to be moved on the machine 1 after the 23 hours only. So in time is the 23 and so for the job J2 on machine 1 processing time is the 12. So 23 plus 12 which is equal to the 35. So next job J2 has to be moved to the machine 2. So here observe out time of the machine 1 is 31 and out time of the machine 2 is the 33. Among these two maximum is the 35. So in time of the machine 2 for job J2 is the 35. So 35 plus 9. So out time is the 35 plus 9, which is equal to the 44. So next, job J2 has to be moved to the machine 3. So here observe the in time of the machine 2 is 44. Sorry, out time of the machine 2 is the 44. Similarly, out time of the machine 3 is the 50. So 44 and 50, 50 is maximum. Then in time is the 50. And 50 plus processing time is the 12. So total time is the 62. So completion time for the job J2 is the 62. So total completion time by the sequencing order J1, J3, J4, J2 is the 62 hours. So next we have to find the total completion time for the another sequencing order, that is the J1, J3, J2, J4. Okay, so next we have to determine the total completion time for the second sequencing order. For this one, draw the tabular column and have to fill the first column is the job sequencing order, that is the J1, J3, J2, J4. Then first job is the J1 has to be moved to the machine 1. So in time is the 0 and out time is the in time plus processing time. So that is the 3. So 0 plus 3, which is equal to the 3. And machine 2 in time is the 3 and out time is the 3 plus 8, which is equal to 11. For the machine 3 in time is the 11 and out time is the 11 plus 10, which is equal to the 21, and completion time is the 21. So next for the job J3, so in time is the 3 and out time is the 3 plus 8, which is equal to the 11. And next one is the for the machine 2, and have to here compare the out time of the machine 1 and machine 2. Here both are having the 11 only, so in time is the 11 and out time is the 11 plus 6, which is equal to the 17. So next once again I have to observe the here out time of the machine 2 and machine 3 both are, so here 21 having the maximum, so I have to enter the maximum time, so that is the 21. So 21 plus 13, which is equal to the 34, and total completion time is the 34. So next I have to move to the next job J2. So on the machine 1 in time is the 11 and out time is the, so 11 plus 12, which is equal to the 23. And next 23 and 17, maximum is the 23 and out time will become the 23 plus 9, which is equal to the 32. So next among the 32 and 34, so maximum is the 34. So 34 plus processing time is the 12. So 34 plus 12, which is equal to the 46. So total completion time for the job 2 is the 46. Next we have to move to the job 4, J4. So on the machine 1, so in time is the 23 and out time is the 23 plus 12, which is equal to the 35. So next to 35 and 32, maximum is the 35. So write down the 35, that is the in time for the machine 2, and 35 plus processing time is the 10. So 35 plus 10, which is equal to the 45. So next I have to compare the 45 and 46. Maximum is the 46 and out time is the 46 plus 16, which is equal to the 62. So total completion time is the 62. So here observe for the both of the job sequencing, total completion time is the 62. So this is the solution, and thank you.